Hello and welcome to the Stars of Physics. In this video, we shall see what happened when we consider resistances in series. So I will draw these resistances and we will find out what will be the equivalent resistance when we have different resistances in series. So this is our first resistance. Say I will call it as R1. Then in series with that, I will connect the second resistance, that is R2, and then we have R3. So this is R1, R2 and R3. We can have n number of resistances here. But what I will do is I will connect these three resistances first, and then we'll try to find out what will be the relation for the combination of these resistance in the series, and then we can generalize that for n number of resistances. So after connecting this, I have to connect a current meter here. I will connect a current meter, and I will connect a battery, that is supply over there, and again I will connect it back to the circuit is completed. Now current I will flow this through this circuit, and the current will be the same throughout this circuit. The same current will flow through this circuit, and the voltage drop across each these resistances we can measure by connecting a voltmeter in parallel to this. Say I will call this as a voltmeter number 1. I will connect it here, and this will give us V1. Then I will connect this voltmeter number 2. We will call it as V2, and we will connect a voltmeter number 3 across the resistance R3 to get V3. And if you want to measure the total voltage across this series combination of these resistances, we have to connect another voltmeter, and I will call that voltage as capital Phi here. Now remember, the current throughout this circuit is same, but the voltage will be different. Okay. Now voltage will be different across these resistances, of course. So same amount of current I is flowing through all these three resistances and their combination also. Okay. So the combination of these resistances in series, I will call it as RS, suppose. That is a series combination of these three. Then according to Ohm's law, voltage is equal to I multiplied by the combination of these three. So it will be V is equal to I into RS. Now similarly, we can apply Ohm's law for all these individual resistances. So I will call this as our equation number 1. Then we will have these three resistances. For these three resistances, the voltage drop across these three resistances will be V1 is equal to I will be same into R1. Then we have V2 is equal to I into R2. Then we have V3 is equal to I into R3. I will call these equations as say 2A, 2B and 2C say. Then the voltage drop across all these three resistances will be nothing but what? Sum of these voltages. That means we will get here our capital Phi is equal to voltage across first resistance, that is V1, plus voltage across second resistance, that is V2, and plus voltage across third resistance, V3. So we will call this as an equation number 3. Now if we substitute the values from equation number 1 and equation 2 ABC in this equation, what we will get here? We will get here I multiplied by RS is equal to I multiplied by R1 plus I multiplied by R2 plus I multiplied by R3. Now this I is common here everywhere. Therefore we can cancel that I. So I can cancel this I over throughout here. So therefore what we get here is RS is equal to R1 plus R2 plus R3. So this is nothing but the combination of series, three resistances in series. Now in general, if we have say n number of resistances in series, say for example I have this first resistance, then we have second resistance, then we have third resistance, and so on up to n number of resistances in the same way. So this will be our R1, this will be our R2, this will be our R3, and ... this will be our Rn. Then this series combination will be given by Rs is equal to R1 plus R2 plus R3 plus so on up to Rn. So this will give the equivalent series resistance when all these resistances are connected in series. I hope that you understand this. If you have any difficulties, you can ask me in the comment section, of course. Do like, share, subscribe and comment. Thank you very much.